Hello, in this video I'm going to show you how to store a password. So in the previous video we kind of created this form, not really, but I showed you how kind of how to process it a little bit. So basically we've reached the point where we're ready to start storing this information in a table. So we'll talk about some basic security concerns. It's a short video, right? It's not comprehensive on the subject. Here's my form. Let's go have a look at the code. So the first thing to look at is my form. I know there's a video before this, but if you're joining here, it's okay. My method I'm using is post. The action is the form itself. I'm passing around something called uname, pass1, and pass2. That's what you need to know. Up in here, I have a little is set determining whether the form was submitted. I verify that the passwords match, and then where I left off was this little chunk right here. This if block here represents a situation where I've verified that the data is good and I'm ready to insert it. And so the first thing I did in my last video was created that table. So that's everything you need to know about the table. It's called YT login. It's got a primary key, a uname, password, timestamp. Now it's time to insert some things into that table. So I'm going to do it naively first, and then we'll talk about why that's a problem. And then we'll talk about why you need to hash it and how to hash it. So I'm just going to paste in a block of code here. So MySQL is insert into YT login, uname password, where values uname password, right? So I'm inserting the stuff I got from the form up here. It's sanitized. I'm going to save this. And I'm not sure where I'm at in the refresh cycle exactly. I don't know if that inserted a row or not. It probably did. So I'll say can, and we'll do something really easy like ABC. And I will submit. And I think that's going to carry out an insert. Now the problem is I don't have any feedback happening, so I don't actually know if it worked. The only way to know if it worked is go check out my table. So here's YT login. I'm going to browse it, and I'm not sure what's going to be in there. So I was just pressing some buttons, but that's the last row that I did. You can tell by the timestamp I did something a minute ago. So, right, can ABC. That was the username, that was the password. That is permanently stored. So when I go to log in to this account, those are my credentials. Now you probably don't have to put too much time into thinking about how many ways this is problematic. So in one sense, this is problematic because I'm a system administrator. Imagine that I have 100 users, right, or 1,000 users, or 1,000,000 users. Well, I have this wall of usernames and passwords, and that's just not. I mean, I'm an ethical guy. You can trust me, but it's not. I don't need to see that, right? I mean, what if someone else who has access to this isn't so ethical? What if there's a security breach and someone gets access to this table? It's just not acceptable to have this list of usernames and passwords. You hear about this all the time in the real world. Whenever there's a data breach, they always say, oh, don't worry, they didn't get any passwords because they hashed them. Right? So I'm going to show you what a hash looks like. And there's different kinds of hashes. I'll show you a hash. So basically, this is right. But we don't want to just store that password, because if we do, we're creating this list of usernames and passwords, and those are probably people's usernames and passwords on other sites too. So quite simply, all I'm going to do is this, and so I like to write it like this just to make it easy to see. So I'm going to create this thing called hashed, and hash is going to be equal to a call to a function called hash, and the hash function, the first thing you pass it is the name of the hashing algorithm you want, like SHA-512. There's lots of hashing algorithms that they used to use that they don't use so much anymore. The world of what's the best hash, how should I solve my password, which some we'll talk about at some point. There's not definitive answers to those things. People have debates. Anyways, so there's different hashing algorithms, and the thing that I want to hash is called pass1. And so this is going to be kind of interesting. So I'm taking that password and I'm hashing it, and then instead of inserting pass1, I want to insert hashed. So what's a hash? So a hash, basically it takes that password and it scrambles it up. A hash is a one-way function, which is kind of an interesting thing to think about and understand. I'm going to refresh, and when I refresh, it'll insert that same user again into my table, and I'll show you what it looks like now. So if I browse, same thing, right? I literally pressed refresh. So now this is Ken, and my password's still ABC, but now it gets stored as a big string of garbage. That's ... right? It goes longer. So you can see why this is an improvement. Now me as a network administrator, I can honestly say that I don't know this guy's password, because I don't, right? It's just a string of stuff. Now this is not encryption. Encryption's different. In the world of encryption, you scramble something up and the receiver descrambles it. It doesn't work like that. Hashing is fundamentally different. Hashing is a one-way thing. It takes that and it turns it into that. Looks like random gibberish to you and me, and that's good. Now the kind of weird thing, one thing I think I should show you, I'm going to refresh this again. I'm going to show you one of the interesting things to talk about with a hash. And as I browse again, so notice it's that random string of garbage, but it's the same random string of garbage. So, even though I don't know this guy's password anymore, because it's just this big string of stuff, you can kind of see, like, imagine if someone had access to this, you could recognize that some of the people had the same password, and ABC is always going to hash to this value. So that hash function, it transforms it, and it looks random, but it's not random. So there's this other issue that you need to know about, and we'll start talking about salt soon, and that is the idea that, well, there certainly is such a thing as like a list of the 100,000 most common passwords, and most people use those passwords. They shouldn't, but they do. And then, so you can imagine if lists like that exist, well, there's also lists of those 100,000 most common passwords through the 20 most common hashes, right? So every time a guy uses ABC as a password, it's going to look like this through a SHA-512, and those are called rainbow tables. That's all the most common variations of the common passwords. So in order to combat this, we use a technique called SALT, and so I'm going to show you where SALT fits into the equation in the next video. Thanks for watching.